everyone, welcome back to Code Insights. So in this new video, we are going to talk about graph representation using adjacency list. So I will explain this topic in a very simple way so beginners also can understand this concept very easily. So let's get into the video. First, let's see what is a graph is. A graph is made up of nodes, also called as vertices and edges, which are connections between nodes. So as an example, we can say in a city is full of roads, the cities are the nodes and the roads are the edges. So what is an adjacency list? So an adjacency list is a way to represent a graph using list. So for each node, we store a list of all the nodes that are directly connected to it. So in simple words, the adjacency list answers the question which nodes are connected to me. Now let's see how to represent the nodes and edges. So it's very simple. Each node is stored as a key or an index, and each edge is stored inside a list connecting to that node. So every node has its own list of neighbors. So now let's see a simple example to get the knowledge of adjacency list. So you can see this simple graph with 4 nodes A, B, C and D. So the connections are A is connected to B and C and B is connected to D. So the adjacent list will look like this. A is connected to B, C, B is connected to A and D, C is directly connected to A and D is directly connected to B. So this means A is directly connected to B and C. So now let's see a comparison between adjacency list and adjacency matrix. So if we see what is an adjacency matrix, an adjacency matrix uses a 2D array. So rows represent source nodes and columns represent destination nodes. So if there is a connection, we write 1, otherwise 0. So the usage of these two the comparison is adjacency list use less memory, and it is best for sparse graphs and easy to traverse neighbors. When we take adjacency matrix, it uses more memory and best for dense graphs, and it has faster edge checking. So what are the advantages of adjacency list? So adjacency list is very memory efficient and it is easy to understand. And adjacency lists are widely used in real applications and it is suitable for large sparse graphs. So as an example, adjacency lists are used in social networks, road maps and computer networks. So adjacency list is one of the most important and efficient graph representations. So understanding adjacency list is essential for learning graph algorithms. So I think you got a clear idea about how to represent the adjacency list and what is the important and at what times we can use the adjacency list. So thank you for watching and let's meet in the next video.